Hey ladies and gentlemen, here's set 49. It's on linear intercepts and transversals. Really short stuff we've already looked at. So linear intercepts. So sometimes we're given just a slope and a y and a ordered pair. We need to find the y-intercept. So we can do it two ways. We can use our slope-intercept form, or we can use point-slope form. Either way is going to work. They're both going to get us the same thing. All right, so let's go ahead. We have our x and our y. We're going to plug in. So 7 goes in for y. -2 in for our slope. -4 for our x plus b. We get 7 equals 8 plus b. I want b by itself because that's my y-intercept. So I'm going to subtract 8 to both sides. So b equals -1. So if I plug it back in, I have y equals -2x minus 1. Okay, if I do it with slope-intercept or point-slope form, I'm going to get the same thing. -7 equals -2 minus -4, turn to plus positive. Y minus 7 equals, I'm going to go ahead and distribute. And I'm going to add 7 to both sides. And you'll see I have the same equation for both. So it doesn't matter which method you use, you're going to get the same thing. Here's another problem. Our slope is -3/4 and our line goes through 12, -9. I'm going to go ahead and pause my video and I want you to do the same. Try out this problem and then come back and you'll see my answers and I'll do it in both methods. All right, so taking a look, both methods, I end up with the same thing. Y equals -3/4 x, no y-intercept. If you didn't get that, pause the video here, go back in, find the method that you did, and check your math with it. All right, transversal. We talked about transversals in geometry, just in Unit 2. It's a line that intersects two other lines on a plane. And a reminder, it does not have to intersect two parallel lines. But if it does intersect two parallel lines, we have some nice congruence statements that we know, such as interior. Alternate interior angles are congruent. Alternate exterior angles are congruent. Consecutive interior are supplementary, corresponding. We have all of those angle relationships. And we're going to use those angle relationships here. We have two parallel lines as marked by the red arrows. And we are going to solve for A and B using just the information we're given. Now, we see the angle 86 down here. Using our knowledge about corresponding angles, I can put an 86 up here. So now I'm looking at this right triangle, excuse my drawing, 12, B, and A, and now I can use my trig functions, and I can go ahead and find A and B. So looking at this triangle, my A is my adjacent, my B is my opposite, and my 12 is my hypotenuse. So to find my A, I'm going to use cosine of 86, which is adjacent over hypotenuse. And I'm going to multiply both sides by 12. So A equals 12 times the cosine of 86. All right, take a moment and punch that into your calculator. 12 cosine of 86. And we end up with 0.837. Okay, so let's set up to solve for B. We're going to use sine of 86 equals opposite over hypotenuse. So I'm going to multiply each side by 12. So now we're going to take 12 times the sine of 86. So punch that into your calculator. And we get 11.97. Okay, so using just our trig functions and what we know about congruent angles. Here's another example. This time we know this angle is 127. Oh, these lines are parallel. So I can transfer my 127 up there for congruent or corresponding angles, excuse me. So I know that the 127 and this angle here are going to be supplementary. So if I take 180 and minus 127, I get 53 degrees. So that angle's 53 degrees. So now I'm looking at this triangle, 71, B, and A. Go ahead, I want you to take a minute to solve for A and B. I'm going to pause the video and I'm going to do the same, and then you can come back and see how you did. Okay, take a look, see how you did. If you didn't get the same answers, pause the video, go back in and look, and compare your work to mine. All right, and there you have it for set 49. Have a good day, guys.